Welcome to Mr. Wilson Live. It is, let me see if I'm getting it right now. It's Thursday, right? Great. It's Thursday, so we have Friday, Saturday, Sunday left to get ready for the CSEC biology examination. I know that a lot of persons are panicking, not too sure what they will do. However, I'll be with you come Friday, and again, I'll be with you on Sunday going through some past papers. Today as well, I want to show persons how to access the information on the channel, and I love to as well go through two questions with you before I leave to get some other things done. Not too sure what's happening out there in the real world. I know that some person had a break today and some persons will be having a break tomorrow. Now tell me in the chat if you can hear me. I'm not too sure if you can. So I'm just going to hop on over to chat to see what's happening. Good evening, good evening. I'm seeing Mark Milan. How you doing? Is this a good evening for you? Hi, how you doing, Zaril, Zari? And Lynn, I'm seeing you as well. Good evening and welcome to the show. I really want to be here with you guys. I am just coming in from work and I decided I'm going to stop by. I'm going to be going through two questions. And then tomorrow, I'm going to be unloading some past papers. Sunday, I'll be unloading some past papers. I'm not too certain what will happen for Saturday, but I'll be going through some past papers, at least between 4 and 5 past papers we're going to be covering between and Sunday. So we're going to be here. There are some videos that I want to share with you, and I also want to assist those persons who are not certain where to find the information on my channel, how to access whatever it is. Now, I observe from the statistics that persons are just seeing 2 of the biology videos that we have. For the greater part, that's what I'm seeing in the stats. So I'm going to be showing you how to access this bit of information, being that we're here and we are using this platform. I want to say good evening to everyone. It's customary that I call persons by name. So I'm going to be calling persons by name, and then I'm going to be upping on over accessing information on the channel, and then I'm going to come back and I could show you some papers or I could show you some videos, and then we get into the paper. So Mark Milan, big up yourself. You're always here. Welcome back to the show. Zari, big up yourself. It's the first time I'm seeing you. Be reminded to like, share, and subscribe. Lynn, I can't remember either, but good evening and welcome to the show. Gray, good evening and welcome to the show. We're going to be here tomorrow even starting at 5:05. And we're going to be here again on Sunday. I'm not too certain what will happen for Friday, but we're going to be unloading some paper too, because we already have the multiple choice out already. So we're going to be going through some paper too and through some problem topics that usually appear on the paper. I'm seeing Naldo. Good evening and welcome to the show. When is bio exam? I heard that the bio exam is on Monday. That's what I heard, and I think HSV will be about Wednesday there about. Winter, good evening and how are you? Garwood, good evening and how are you? Small, good evening and how are you? Miller, good evening and how are you? I'm seeing a whole lot of new names, but welcome to the show. I'm not sure if this should be cakes or I'm not too sure what that is, but good evening and welcome to the show. Zaria, hi, how you doing? Sorry for slaughtering the name. I'm seeing Khan. Welcome to the channel. It is CSEC Biology TCP, and we have been here over a year now, doing live classes on a Wednesday, Friday, and Sunday. Barrow, welcome to the show. I realize that I'm just seeing one person that I know. I'm not too sure. Well, it's not my event for blogging, so of course my fan base wouldn't be here. Pinto, welcome to the show. Brisset, welcome to the show. Mark Milan is, of course, a fan. It's not a bad even at all. Thanks. Mark Milan, you're doing biology or HSB? Yes, I'm hearing great. Miss Chemistry, is Miss Chemistry now or Miss Biochemistry? Is it the same person? Good evening. Yes, I am hearing you. Miss Chemistry, are you a teacher or a student? Let me know, because if you're a teacher, I could just pull you on over and we share the evening. All right. Good evening, Mr. Wilson. Hi, Winter, Vanessa Winter. Good evening. Peter Gay Campbell, good evening. Nelson, good evening. I am hearing. All right, great. Sir, I'm sorry if I am forgetting anyone. I'm getting really old. I tell you that the days are moving so fast, and so to my age. I am seeing is I think it might be Antoine, good evening. And I am seeing Shari, good evening. I am seeing Walker, good evening. I'm seeing Winter, good evening. I'm doing HSB. Well, it's good for you to be here because most of what I'm doing a bio paper this evening, however, but I continue to say to the bio student and HSB student, you can practice on pretty much the same papers. Of course, there's a plant aspect to be covered, but when it comes to practice, just become a guru at it all. I'm seeing Small, good evening and welcome to the show. I'm doing HSB as well. That's fine. You're at the right place. We're going to be doing something that is pertinent to both topics. Usually that's what we do. Silveria, good evening, and I'm seeing Naldo. All right, great. So the first thing I want to do, I realize that numbers is up on the channel. Yeah, I follow the stats a whole lot. So I realize that some whole lot of persons view the channel today. Good evening, Sadiq, I think so. Shari, good evening. All right, great. So other persons, I'll just say a general good evening to you. And now I'm going to up on over just to show you how to access the information on the channel. So I'm going to be sharing my screen. Just give me a second as I go over to pull that information. So here we are. Where are you? Good. So I'm going to share. All right. So I'm not seeing you. I don't know if you are seeing me. All right. You're seeing the screen, right? Just tell me if you're seeing. If you're seeing, just say yes, we're seeing. And I think most persons will be hearing. Are you seeing the screen well? Everybody seeing that well? All right, great. So I'm going to go on into the screen. So when you log on to YouTube, in most cases, you're going to be seeing something like this. So probably you want to find CSEC biology. I'm seeing we're all over the place. CSEC biology, TCP. All right, so you could look for CSEC biology, TCP, or CSEC biology, the cover page. So usually you're going to be seeing this blue icon here. It's not loaded as yet. This blue icon, if you're watching one of my video, that's me there. If you're watching one of my video, you're going to see that blue icon somewhere. System is very slow. You're going to see this blue icon somewhere. All right, system is very slow. So these are just some of my videos, some of the many. I think I have over 300 or something. All right, great. So what you do, you just click on this blue icon here, and having clicked on the blue icon, it will take you to the back end of the channel. Now you have two options when you get to the back end of the channel. You can go into videos, which is going to take you into a myriad of videos. You might very well get lost around here. So here we have, like I said, we have over 300 videos, and we would have covered both syllabus, or should I say, is it syllabus or syllabi? I don't even remember. We would have covered all that for both bio and HSP. So there we have a whole lot of videos. But not many persons can scroll through this. It might be time consuming and a little troublesome on the eye with the number of videos that you're looking at. So you could just go on into the playlist right here. So you go to the channel, you select the playlist, and this might be a little easier. So when you get to the playlist, we have some 6 to 7 videos as short videos, and we have other videos. So let me just go through. I want to find what is pertinent to you. So this is CSEC Biology 2021. These are some topics to be covered. And I want to show you what you want to see. You want to see the past papers. So just let me try and find that. All right, so this is the playlist here for the human and social biology paper. We have 24 videos in this collection. For those persons who are having problem with genetics, it's all covered here. We have 12 videos made exclusively for CXC. For those persons who want to do biology, let me try and find that one. Okay, great. We have 24 videos here for us biology past paper. So we're talking about the past paper. So for the biology past paper, we have 24 videos, and for the human and social biology, we have 24 videos. For those persons who are struggling with genetics still, we have a playlist here on genetics, and the videos are not so long. They are built for CSEC. And we have the labs for those persons who are doing the alternative paper. Just let me show you the lab. It's a biology experiment. There are 24 experiments in this, but I'm sure that there's another playlist with experiment. There is also the biology skills that persons need to know that include the ORR, MMAI. They are well explained here, and there are a number of animations. When you go to the labs, you are going to realize that there's a whole lot of animation for you to treat with. So these are not all the videos are in the playlist, but the ones in the playlist, more so those that are for your past papers, they should help. Now, over here, you will realize that we have Mr. Wilson Live. Mr. Wilson Live would have been the entire syllabus for both biology and HSB. Not all the videos are in the biology Mr. Wilson Live playlist. So you probably want to check out the playlist, and then afterward, you can look for whatever else you need. Or probably you could just send me a message and I see how best I can help. All right, that said, so let me just move away from that, and we could probably just share something from my platform. Just give me a second. All right, stop sharing there. You should find the videos. So once you type in CSEC Biology TCP, it's CSEC Biology TCP or CSEC Biology the cover page. So it's CSEC Biology TCP. All right, and you are seeing our paid channel scrolling at the bottom of the screen. So those persons who want to do biology next year, and you need to find past papers that are worked and explain paper 2 if you want to find an alternative paper. We have that online. If you want to just find a particular topic, you could just pay for the topic and not for the entire course. So you could pay for the full course for the year. You could pay for a single subject. You could pay for a single topic. You pretty much dictate the pace that you're paying for. One thing I can say is that the classes online, they are way cheaper than if you were supposed to go face to face. Another thing is that we use a whole lot of animation in our delivery. So cases where you're having problem, we have animations that should be able to assist you. As you can just peruse the files that we have on CSEC Biology TCP, you would have seen a lot of files there. Might I also introduce us? Just bear with me. Let me just give you these things, do the homework before we leave. Sir, I think I am in panic mode. Can you give some tips to get out of that mode? All right, great. Great, that's what we do here. Good evening. Sir, I am unable to find my name on the candidate listing at this time after paying for the exam. Jawawan, I am a little disappointed here. Do you have the receipts? Did you check where? I don't know if you signed up as private or if you actually you're with a school. So if that is the case, you probably want to inbox me and I could give you some advice. Macmillan, Jawan, where are you from again? All right, I had that same experience, same issue. How was it resolved? And I had to be behind the ministry. All right, so a whole lot of things going on here, a whole lot of persons talking. If I miss what you would have said to me, just retype it with some asterisk in front of it so that I can revisit. But it's going really, really wild here, and there's a lot that I want to cover. I want to also remind us before we get into the past paper, I have 3 books coming out this year. I would have, one is in the post, the first book to come out. It's a nice book that pretty much epitomizes the journey to success. There's a lot of lesson to be learned from that book. And then we have another one has to do with the medical field, but of course it is a story that we're putting out. We also have a new series of books coming out for sciences. Like crossword puzzle, word search, and the whole gamut of stuff. We have those coming out for September. So you want to really look out for the CSEC Biology TCP brand. We are in books. A whole lot of books will be coming out. So look out for those as we move forward. All right, so just let me just take one more read, and then I am going to be showing you something on screen, and then I might show you some videos and that type of a thing, and then we move on. So I'm going to look at Macmillan. Remember, guys, you have my email address, so you can just send me the information. All right, so the first thing, let me just deal with this problem. The first thing, if you're having a problem with your name not being on a list, I'm not too sure if you signed up as a private candidate. There's just one way that this can be solved. Contact your regional office, right? You must know where you're going to be doing the exam. Contact them, and that should have been done long time ago from verification. Go in, contact them, and they will advise you as to what to do. Without further ado, let me just share my screen and hop on right into the lesson. I'm having it a little difficult this evening to answer to everything that is on screen. So I'm just going to be sharing one question. I'm going to be walking everybody through the question. I said 2 questions this evening, and then come tomorrow, we are going to be doing much more. So let me see what we're going to be doing here. I want to look at this here. So we're looking at the much needed exam. Persons have been asking us for the 2019. So this is the 2019, and for those persons who have never done CXC before, this is what the CXC paper usually looks like. But you want to make sure that you read all the instruction here before you get into the exam. So there we are. So we are going down, we are going down, we are going down. All right, might I say I have never seen a question like this before for CXC. That's the first thing I need to tell you. I have never seen a question like this before for CXC. I'm going to just give you the question. You won't be able to see me. And then we can talk about it as we move along. All right, great. So there it is on your screen. Now we are looking at this question. And many persons are wondering, what is this equipment? Some persons have never seen it before. Some persons would have seen it before, but they have never used it before. Some persons are saying that we have seen this equipment at the clinic, but we're not too sure how it works. All right, so I'm going to be showing you a couple of things, and then we're going to be going through the question. So let's read what it says. It says, figure 1 shows apparatus that was set up to measure the rate of transpiration of a potted plant located in a room beside an open window. And this experiment was done pretty much over a 12-hour period. Now we're seeing the well-watered plant, important to note, well-watered plant, and we're observing as well that it is tightly sealed. It's in a tightly sealed polythene bag that pretty much encloses the pot and the soil. And then we know that this apparatus is what we refer to as a beam balance. I want you, for those persons who have never seen it, you are observing you have 1 shaft here, 2 shafts here, and then we have 3 shafts. Now on these shafts, we're going to have some little things looking like weights. All right, we're going to have some little thing looking like weight. Just let me just change my color here. Everything seems to be going slow. All right, so let me get a bigger pencil. All right, great. So you might have some little things looking like weight and they're hanging on it, something more like that. And you might have 3 of different size. Probably one is about 1, one is probably about 10, the mass of the other is about 10, and probably the mass of the other is about 100. All right, great. So just let me come on over and just talk to you a little about that. Using the balance. We start at 0. Now, if you have never seen it before and it is causing some bother, the only thing you need to recall is that it is a balance like any other balance that you have used. If you went to the market and you fetch yourself some fruits or you fetch yourself something that they use a balance to measure, then you understand that all that it does is to record mass. Now we observe on this paper that it said weight. Now weight is incorrect because to find the weight, you'd have to multiply the mass by 9.8 to find the weight. So we're actually finding mass, right? This is not a physics exam, so we're not finding weight, we are finding mass. Great. So in looking at this equipment, it is finding mass and it is measuring mass in grams. Because it's measuring mass in grams, one of the things that we want to ensure that this scale is properly calibrated. So before we use this type of a balance, the first thing that we need to do is to ensure that it is set at 0. All right, so you want to carry back all those weights and you want to ensure that it is set at 0. All right, great. Now, having set the weights at 0, you would have slide them backward. Having done that, the next thing that you want to do is to find the mass, that is the start mass of the setup. Now, the setup here is going to be the potted plant with the polythene bag. So you're going to place the polythene bag with the plant on that flat surface here, the flat surface here. You're going to place the potted plant as it is there. Then what you are going to do, you would have a good idea as to about how much it weighs or what's the mass of it. There are 3 different weights on it. 1, 2, 3. One might be in unit, tens, and 100. Now what you're going to do, you are going to slide the weights away from the potted plant in order for that lever there to come back to 0. When it comes back to 0, what it indicates is that now you are getting the true weight or the true mass. Let me show you something here. Now, while this is looking as it is, this is what it is doing. So we have a straight line and there's a point of pivot. Let us use a point of pivot here. All right, so that's a pivot point. Now it is at 0. We all can agree that this side is at 0 and that side is at 0. Now, if we were supposed to put a potted plant or put a plant on it, let us just get a plant in here. If we were supposed to put a plant on it there, what would have happened is that this would have tipped up. This would have tipped up, so this part here would have gone up in the air. Now, having gone up in the air, we need to get it back to come to 0 right there. All we are going to do, the weight that are on it here, we are going to move the weight one at a time. Preferably, you want to use the weight that is closest. We call the things on it weight. We want to use the one that is closest to the mass of the potted plant. So as we move it, what will happen is that this line here will lower and lower until it gets to 0. Now, suppose when we move the weight, we had to move 215. If we move the weight here and we had to move it to get 215 grams in order for the needle here to come back to 0, it suggests, therefore, that the mass of the potted plant, of the entire content here, would have had to be 215. Now, it is only if both sides measure 215 that it will come back to 0. So if we have 215 on this side, 215 on this side, then no side of the balance will tip. And that is pretty much how we measure the mass here. So let us look at the question. If you are writing there, I'm not seeing the screen right now. I'll get back to you just in a bit. Remember, if I'm missing you, just put some asterisk in front of whatever you wanted to ask, and I'll get right back to it. All right, so let us look at this. It wants us to describe the procedure that uses the apparatus in figure 1 to investigate the rate of transpiration of a potted plant within the 12-hour period. Now, while we are measuring a plant here, the HSB student would have been measuring a baby or they would have been measuring an adult. So they would too use a balance like this, providing that the one that they would be using is a standing balance. Now, what I want you to do is just very quickly, I'm gonna make the procedure, write the procedure there in the description. Let us see how well you are working with it. So write me the procedure that we would use for this particular experiment. How would we find the rate here? That's what it's asking. Just let me check again. All right, so we want to describe the procedure that uses the apparatus shown in figure and to investigate the rate of transpiration. So how would we use this to investigate the rate of transpiration? How would we use this setup to investigate the rate of transpiration? Is there anybody who can answer? If you can't answer, just say move right along, sir, so I get right into it and we don't waste any time. Anybody can type that. In fact, if you can't do it, you just can't do it. Or can I zoom in the paper? Oh, you're not seeing. All right, move along. All right, great. I'm not too sure how to do that zoom in thing. I'm not too sure how to do that, but I can read for you like I have been doing if you're not seeing it. I'm sorry. Or probably I need to go back here and do this. All right, I hope that will help. All right, great. So move along. All right, great. All right, so to use this balance, it's like using any other balance. Now, to find the transpiration rate, usually, we use what is called a potentiometer, right? We use a potentiometer, but we're not using this one. This is a simpler setup, one that most persons would be using in school if you don't have the money to buy these expensive gadgets. So the first thing we want to do here is to ensure that the balance is zero without the plant being on it. So you're going to set the balance to 0. That's the first thing. The second thing you're going to do, you're going to load the plant or the specimen. It could be a baby, it could be a human. You're going to load the specimen onto the stand area here. Having done that, the next thing you are going to do, you are going to move the weights along this area here in order to get the lever to come back to 0. Having done that, acquiring that 0 mark, the next thing you are going to do, you are going to record the reading. Now, that reading is going to be the reading we refer to as a start mark. Take the reading at 1 hour intervals. So thereafter, you're going to be taking your readings at 1 hour intervals. So remember, to use this balance, it's like any other balance. First thing you want to do, 0 it. Second thing you want to do, load the thing on it. The difference with this is just that you have to move those weights to ensure that it get back to 0 so that you can find the mass of a plant or the specimen. The other thing you should do when you are reading from any scale is to ensure that you are reading directly in front of the scale. Directly in front of those writing on the thing, make sure that you are reading directly in front of the scale so as to avoid parallax. All right, great. So let us look at the other question. I hope that person's, okay, somebody tried to answer. Great. So let me look at what is happening here. All right, so collect the apparatus, place a well-watered plant on the beam balance. No, you have to zero the beam balance first, but this is a good attempt. Measure and record the initial weight of the plant. All right, so just one thing, point 2, we want to ensure that for point 2, the first thing you have to do, you have to zero it. Make sure that it is 0. Whatever balance you're using to find mass, you must either you're going to tear it first or you're going to zero it. Whichever one is going to be good. All right, let's look at the other question on this paper. All right, I do hope that persons understand that bit. 4 marks for that, not much. Now, the next thing we want to do, we want to state one precaution that should be taken to ensure that the results are accurate. Now, tell me in the chat now, this is going to be easy. One precaution that you could take to make sure that that the reading is accurate. One precaution that you could take to ensure that the reading is accurate. Tell me in the chat, one precaution. So we're looking at things now that if they are not followed, then the experiment result could be skewed, right? It could be based on chance result. So you are to ensure you read the measurement at eye level. That's one. Could anybody give me another? Ensure that the beam balance is 0. Very good. Could anybody give me another? About 2 more. We could find at least 2 more. 2 other things that we could do to ensure, all right? Ensure that the scale is read properly. Yeah, but that is sort of vague. Being that you're a science student, you want to say what properly means. I am just joining, sir. That's fine. Welcome to the show. Now, read the measurement at eye level. What is the question? We're answering question II. It says, state one precaution. It's on screen. That's the one that we're looking at now. All right, great. All right, so another thing that you need to do, you have to ensure when you're carrying out this type of lab that the polythene bag, it's not torn. Now, if a polythene bag is torn, what you're going to have happening is that you're going to have the water evaporating from the soil through the bag. You'll be losing water from the setup, but it is not as a result of transpiration, which would have affected the result. Another thing that you want to ensure that the bag is firmly, tightly fitted to the plant. You probably want to put some petroleum jelly around the head of the bag so as to ensure that there is no movement of water in or out of the setup. All right, great. The other question we want to look at is to suggest 2 factors that may affect the rate of transpiration of a potted plants. Why do you have to read the triple beam balance at eye level? Well, the truth is you want to read anything that you are taking the reading from. You could be in an industrial setup and you are reading, and it might be above, below, to the side. If you read to the side, you still will expose yourself to parallax. You still will expose yourself to parallax. Whatever it is, you might not get the true reading. And we want to ensure that our students are practicing the right thing at all time. It doesn't really matter. When they become pro, if they can do that without parallax, that's fine. So I understand that person might be saying, hey, it's a triple beam balance. Once it's at 0, it's fine. But even when it is at 0, we need to record the correct weight or the correct mass. All right? If you have something different, I will definitely accept. We are going to look at that. All right? What's the question? Placed on flat surface. Yes, flat surface is important. Why would you? Okay, we address that. Balance is working properly. Yes, because sometimes they have some amount of rust and they are not reading properly. So that's a very important thing. Temperature and light. All right, temperature, humidity. Very good. Those are good answers. Temperature. All right, ensure measurements are accurate. Yes. Wind velocity, or one might say wind speed. Yes. Light intensity, temperature. All right, good. So all these are limiting factors to transpiration. We can think about 4 very, very quickly. Sorry, sir. Is this HSB? If it is, I don't know about that you are teaching. I am pretty much teaching bio HSB somewhat. I am definitely not teaching, say, on your syllabus as to HSB. We're pretty much teaching how to find mass. And if you know that this year HSB has some amount of labs in it, but it's very important for any student that would be doing HSB to be able to read a triple beam balance. Because when you go into the medical facility, these are the balance that you're going to be using. So don't worry yourself. Your part of the thing will come up shortly. All right, great. So there are 4 limiting factors we can think about for transpiration. They are going to be humidity, wind speed, light intensity, and temperature. These are things that persons want to look at. Now, for those persons who are still having problem remembering these limiting factors, those factors that are pretty much helpful in getting the clothes dry on the line, those are some of the factors that we're looking at when we're looking at factors which affect the rate of transpiration. Let's move on to the other question if there are no questions from you. So we would be getting 2 marks here, and for the limiting, for the precaution there, we'll be getting 1 mark. And this is, of course, biologic for those persons who are a little confused because they have not seen those questions on HSB. But we measure things in HSB just the same. All right, so look at this one. I have never seen this on a paper before, but to me, it's pretty easy. I don't know how many students will find it to be easy, but I think it's a nice question. It says that the graph in figure 2 was constructed using the results obtained from the investigation in A, which measure the rate of transpiration over a 12-hour period. I remember that we're looking at the biology May 2019 paper, paper 2. All right, great. So we're looking at the rate of transpiration, and when we look at the rate, it is talking about how fast something moves. And as it were for transpiration, we're looking at the movement of water in and out of the plant. And you'll soon find out why I said in and out of the plant. Now, look at the graph that we have here. We're going to move this information from the graph onto a table. Now, if you have seen my previous live on graph, or you've seen the live questions that I've done on graph, you've never seen me doing a question like this. But this one is going to be a real interesting one for both biology and HSB. So here we want to look at the x-axis, the y-axis first. So the y-axis here pretty much shows the mass of a potted plant. And I keep saying mass. Weight and mass should not be used interchangeably because weight is 9.8 times your mass. All right. So on the y-axis here, we have the mass of a potted plant. Then on the x-axis, we have the time at which the reading was done. Now, let us just move on down a little bit. We're looking at time of the day. In that video, I gave you everything that should be independent variable and dependent variable. Now, be reminded that on the x-axis here, we have the independent variable, and we said something about the independent variable as it relates to your table. I'll be asking for that information again. Now, we're going to be making a table on the other page. Now, remember, all tables must have a title. To get the title for your table, all you need to do is to change the name graph here and replace graph with table. And that would be a nice title for your table. Let us move on and look at the table. I'll come back to you in a bit. It said that we're supposed to draw a suitable table and record the result presented in the graph. So the result that is presented in the graph, we're going to record in the table. So let us just go on and look at the graph. I am going to minimize the screen somewhat to see if you will be able to see everything. And then we'll talk about how we're going to get this information on the graph. All right, so let me come back over here. All right. Okay, yes, I'm going through the biology 2019 paper. I'm going to be doing 2 questions, and then we are going to continue with some more papers tomorrow. All right, great. So we are looking at this. Just let me get it up a little more on your screen. All right, great. So there's the paper. We want to get this paper, we want to get the data here on this graph into a table. What are some of the things that we should be doing in order, what is it that we need to do in order to get it onto the table? First, what's a table? What should a table look like? Tell me in the chat what the table should look like. But we have classes at 5:05 p.m. on a Wednesday, Friday, and Sunday. And we've been doing that for a year now. All right, great. So let us look at what we're going to do with this table. So I'm going back over there to look at the table. You want to follow as I go through. All right, so the first thing we want here, we want to identify the axis. So this here is going to be the x-axis. Very important for us to identify the axis. And this here is going to be our y-axis. Great. When you are constructing a table has 4 sides. All right, great. And you want to use a ruler to draw your table. For the students who are doing biology, you'll remember that the only lab that you are required to use a table for is for the food test. So you would have developed the skills for a lab, for a table. So here we know that we should have a title, and the title must be underlined. We need to have a title, and it must be underlined, and it must be in uppercase. All right, and the title must be descriptive of the table. So here our title is going to be this from the graph. I hope you can see this. Let me carry it up some more. So this is going to be our title for the table. All that we're going to do is to move graph and replace it with table. And that can be our title here for our table. Now we're looking at 2 data sets. We're looking at time, and we're looking at the mass of the potted plant. Mass of a potted plant, and it is measured in gram. So what we need to do, we're going to need to divide this table in 2 because we are working with 2 data sets, right? One data set is time, and the other data set, like we said, mass. So we're going to have a header row. That's the header row there. So what are we going to put where? So we have this column here, we have column 1, and we have column 2. Now, what data do we place in column 1? Now, the data that we're going to place in column 1 is always going to be the data from the x-axis. All right, because that's the independent variable, and the independent variable is usually in column number 1. For column number 2, we're going to use this information from the y-axis for column number 2. So the table is getting a little easier. The other thing that we need to do, we need to put some titles in these areas. Where are we going to get that title? Now, the title that we're going to put there is pretty much the same title that is on the graph. So we are going to be writing in this title here, time of the day. We are going to write it here. So time of the day will be written there. And then we are going to write mass of potted plant here. I keep saying mass of potted plant because the use of weight, to my experience, is incorrect. Should have been mass. All right, so we're going to put that there. But not only are we going to put that there, we need to make note of the unit. Now, mass here is being measured in gram. Weight is actually measured in Newton. So that alone says that this is incorrect. So this here, we are going to put it like it is here, gram right at the end as it is in this header row here. And the same is true for time of day. If we observe going through 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., you would have realized that time there is measured in hours. So you want to write your HRS right at the end of time of day right here. Now, having done that, you would have, and enter the data, you would have secured for yourself 4 marks. So let us see how best we can treat with this. So we want to use a ruler, and we are going to draw a table. All right, so a table, usually it has 4 sides, and it is neatly drawn with a ruler. Some persons will measure, and then we are going to split it down the middle, and then we are going to go on header row, header column, right? And this is pretty much in time. I'm using a little shortcut here, and time we say that is HRS. You can write it down. I am using my keyboard to write all this. And then on this side, we are going to have mass. And mass is measured in gram for this particular activity. We want to put that in a curve brace. And we're going to put the hours here in curve brace as well. And then the next thing we need to do, we need to record what is on this graph in the table. So we could start, we don't have to do any reading because this is independent. We don't need to look anywhere. So we could start recording from 6 to 6. So in the time of day, what you're going to do, you're going to write 6, 7, 8, and the time of day is AM, 9, and you are going to continue until you reach 6 o'clock again. So you continue down until you reach 6 o'clock. All right, great. Now, having done that, it's very important for us to get the mass over here. What we're going to do, we are going to go back to the graph, and we are going to look at the point at which there's interception. So at 6 a.m., the starting mass of a plant was 90 grams. So we can just slide on back down, or we could just write that somewhere, and we're going to write 90, and we don't need to repeat the gram because the gram is already in the header. Now, having looked at that 90, that's what we started with. At 6 o'clock, we started with 90 grams. At 7, we would have seen a decline, or we would have seen the mass of the plant becoming a little smaller than it was. This is somewhere about between 87 and 86 thereabout. We'll get that reading here. All right, we can't see the graph leave very plain, but on your exam, you would have seen it. And if this is here and here, 80 to 90, it suggests that we have 10 here. So in the middle here would have been 5. So it's about 7 here or 8. So we could say that this is 87. And we come on back down to the graph. And we record the 87. So what you're going to find happening, that all the information that is supposed to be here, all that you need to do is to come on over to the graph here and just take off the information where they intercept with time, and you will get it. So here we have 90 intercepting with 6, 7 intercepting here with 87. We have 8 intercepting here again with 87. We have 9, and you see the gist coming across. Wherever there's interception, you are going to record the data in your table. Wherever, and you see continue there. All right, I want to point out something before we get back to the other question. Now, if you look at the graph here, and let me just highlight that for you. I'm going to use another color. If you look at the graph here, it is suggesting that here the mass was pretty constant at 40 grams. And then if you observe here, the mass fell to 39, and then it went back to 40. Now, how could that have been if no water was added to the plant? Now, there's just one logical explanation I can think of. The person who was doing this reading, they made an error because no water was added to the plant. So where would we get back this extra 1 gram of water that we had lost? So you have to pay attention when you are doing your reading. I do hope that that helped in looking at that particular table. So it's 86. Okay, somebody have a paper and they're saying that it's 86. I can't see it very well, but I'm very grateful for that. Okay, was thinking the same thing. All right, great. Yes, so that would have been an error. For sometimes they take these things from students' book. So that's why we tend to have things like those. All right, so just let me go on down to another part of a question. I do hope you understand the independent and dependent variable. All right, great. So there are many graph questions that we have done, just a single question from various years, so as to ensure that you understand how to do graphs. So to do that, fill that table out, construct the table, give the table a title. You would have gotten 4 marks for that, and that is easy 4 marks. Now look at this now. During what time period was the rate of transpiration ice? So the rate of transpiration during what period? I'm going to be showing you the graph. So here's the graph. Type in the chat for me. During what time period? Oh, you need to see the time. So we're looking at time period here. probably need to erase these. During what time period was the rate of transpiration highest? Look at the graph and see if you can tell me in the chat during what period the rate of transpiration was at its highest. That's the question that we're answering. So if you have this paper, you can join us. We're going to be completing the paper tomorrow. I just stepped in this evening just to say that we're going to be having class tomorrow and just to start a little thing with you, just to start the fire blaze. All right, great. So let me see what's happening over here. All right, so 3 p.m., 9 to 11. I am seeing that 9 to 11. All right, so what I want us to do, I want us to pay attention to the whole idea of time period. All right, time period. So let us look at the graph. And we're going to look at the question. So the question, during what time period was the rate of transpiration highest? So it is asking during what time period did we lose most of the water? All right, remember in my lesson on graph, when we looked at these things, we said that is an exponential increase. That is pretty much constant. This curve represents fluctuation. This curve represents a decline. And then we spoke about marginal, that type of a thing. I was told today by the English teacher that is not, it's not on the exam paper anymore. But you remember these, and you remember things like parabola and that type of thing. All these are curves we find on graph. All right, great. So now that we have seen that, we are looking at the time period where the rate of water loss was greatest. Now, if you look here, there is nowhere on the graph that we would have lost so much water. Here we have lost 40 grams of water. Look at that. 40 grams. So here we are coming from here, 80, and it stopped here at 40. So it suggests that we lost 40 grams of water. So your time period would have been between 9 and 11. And I'm sure I saw somebody said that in the chat. Here we have it, 9 and 11, 9 and 11, congrats. 9 and 11, 9 and 11. So a lot of persons would have seen that. You need to make note or know the curves. What this means is that, would that connotate the same meaning as probably that? Definitely not. These are three different curves that tell a different story. So we need to understand that. So just let me just go through this particular curve, what it means there. It suggests that there was some exponential movement. And let me show you what that means. It means that we would have been increasing by 2, 4, 8, 16, 32. So that pretty much shows you this doubling effect. As you go up, there is this doubling effect. So you want to pay much attention to that when you see it in your exam. You really don't want to see it and not know what it means. All right, so let's move on down to the other question. All right, great. Now, I would have answered a question like this on the 2016 biology paper. Now, what we have observed is that 2016, 2019, and I think 2017 all started with a graph. You can correct me if you're a bio student. I think that those papers all started with graphs. Now, let's look at what this one says and what is expected of us. For those persons who can't see what's on the screen, just let me just pull it up a little more for you. All right, great. So you are supposed to suggest 2 reasons for the shape of the graph during each of the following time period. Suggest 2 reasons. What I suggest to my student is that they underline this bit of information. So you want to suggest 2 reasons, not 1. So you need to add 1, and they will probably want to have 2 reasons. Now I want you to suggest 2 reasons for the shape of the graph during each of the following time period. So we are looking at between 6 and 7. Shape of the graph between 6 a.m. and 8 a.m. Sorry. Let us go right back up, and we are going to be looking at that. The shape of the graph between 6 and 7. So here it is, between 6 and 7. So this is 6 right here, and this is 7 right here. So we are looking at what is happening here. You are supposed to explain the shape of the graph here. All right, so tell me in the chat what you think the answer should be. The shape of the graph here, between this line and this line. Tell me in the chat what you think is happening there. All right, so we're looking at this area of the graph. What's happening there? Tell me in the chat. What's responsible for that? So it's a slight decrease. That's a very good answer, but that is not necessarily the answer for this question, because you want to tell why we're having that decrease. Why do we have that decrease? What's the reason for it? What's the reason for that decrease? Yes, what's humidity? You couldn't leave it at just humidity. What about humidity? You couldn't answer the CSEC paper and just leave it at humidity. What about humidity? So an increase in temperature, of course, could have caused the decline in mass, because the plant now is losing water through the stomata. Sir, is it because of the morning temperature? Well, what about the morning temperature? Is it hot or cold? What exactly about the morning temperature? This was because it was in the morning, which had one, low light intensity and low temperature. But hold one bit. When we started out, even though we had low temperature, what we can say for sure is that the temperature was enough for the rate of transpiration to have increased from pretty much zero, pretty much what we have there. We lost about, I think, about 4 grams of water. So something would have happened. So what we're looking for, I'm seeing a lot of the answers here, but they are not properly shaped. That's the only problem I'm having there. There's no fluctuation between 6 and 7. I'm sorry. There's no fluctuation. A fluctuation would look pretty much like this line going up and down. Great. So the reason for this, I'm seeing everything on the screen. It's just that we haven't coined them correctly. What we want to say here is that there was probably an increase or a slight increase in temperature, which caused the plant to have lost 4 grams or lost some water. We could have also said that there is a slight increase in wind speed. We could also say that there was a drop in humidity. And we could also speak about the light intensity. Any of the 4 factors could have contributed to what happened between 6 and 7. All right. Now, our problem is going to come when we have to look at 8 to 9. What could have caused it just to stop and then to start again? All right. Water content of a potted plant was high. Yeah, the water content of a potted plant was high, but of course, we are losing some of the water. And if we are losing some of the water to transpiration, it must have been one of those 4 factors that would have caused us to lose the water to transpiration. Let's look at the other question. So in the other question, we are supposed to, so we looked at 2, we could look at any of the 2 of the 4. Look at 9 to 11. Let us look at 9 to 11. What is happening between 9 and 11? So between 9 and 11, 9 is here, where we have the triangle here. So it's from this line here to this line here. What could have caused this significant decline or this significant loss of water? What would have been responsible for that? We lost a whole lot of water there. What do you think is responsible for that water loss? So we're looking at this area here. that area there on the graph, what is responsible for that? Water loss. Between 9 and 11, the water had suddenly increased in temperature. I wouldn't say there was a sudden increase in temperature, great temperature, and wind speed. That would nicely cover it. Based on what we're seeing, yes, we had this big jump in temperature, or big jump in wind speed, or highlight intensity, or drop in the humidity, and that could have caused us to have this sharp decline or the sharp loss, water loss in the plant. No, we cannot leave it at just saying heat or decreased humidity. The explanation that Khan gave would pretty much want to see you writing like that for the exam. Brittany All, sir, because the temperature in the morning is normally hotter than the rest of the day. Brittany, I would take you outside for an experiment if you were my student, and just to see if you'd have that same concept. Now, Brittany, if you can recall, between 6 and 7 in the morning, would it be as hot as it would have been between 9 and 11? Between 9 and 11 is when you would have been seeing A's in the distance. So tell me if you want to rethink that position. All right. But for those persons who are not sure what the answer should be, if you want to scroll up and look at Khan's answer, that is a good suggestion. Increase in the temperature, light intensity due to the time being increased from morning. It's not so much about the time being increased from morning or the time that time lapse between morning and day, because I'm sure that you can all agree that there are days when 12 o'clock in the day it is cold or overcast. So pretty much the shift in the time of the day might not really affect it. It's not so much the time that is impacting the thing here. It's pretty much those 4 factors that we spoke about that are the limiting factors to transpiration. All right, not so much the shift in time. It could have been in the morning and it's really hot in the morning. It could have been in the day and it's really hot in the day. But of course, based on the timeline that we have here, it is expected that at that time of the day, then it's going to be bright and it's possibly going to be hot. But it's not always going to be the case. So we really don't want to go down the line to say it is because the time of the day. We want to more look at the parameters that we're working with, which are light intensity, temperature, humidity, and wind speed. We want to keep our answers focused around those 4 points. All right, great. Let's move on to the other question. So we're going to be looking at 12 to 2 p.m. And don't be mistaken. I don't want you to just go on the paper and write what you knew about the day, because where you are, it's usually very hot and sunny between 12 and 2. You don't know where I live in the Caribbean. I live pretty much up Blue Mountain top. And if I live on the Blue Mountain top, your experience living on the flats of Kingston or on the Veer Plain would have been way, way different than the person who lives at pretty high elevation, as it were, with the conditions here. I got distracted by something that popped up on my screen. I'm sorry. All right, so we're looking at the thing here between 2, 12, and 2. What would have happened here? So we're losing water all along over these many places. And then now we find that there is no loss of water. Things are pretty constant. What would have been the reason for that? We are not losing any water anymore. How do you account for that, for the shape of the graph here? What would have caused that? All right, so we're looking at between 12 and 2. What's the reason for that? Now, if you're just joining, it's Mr. Wilson Live. We stream on a Wednesday, Friday, and Sunday. Of course, it's the end of the year, and we're looking into September. We have our online school, which is called TCP Academy, We have really attractive price, and we teach right across the Caribbean. We also have over 300 videos on our YouTube channel that are pretty much geared at CXC. So you want to ensure that you go on over and, of course, make use of the content. There are 2 playlists there, one for HSB, past papers, and there's another playlist there for biology past paper. You want to make sure that you treat yourself to that bit of information for your exams. We are going to be online tomorrow evening doing past papers. We're going to complete at least 1 or 2 past papers tomorrow. And again, we're certain that we're going to be online for Sunday. While we're not online, we do encourage you to partake in the many past papers that we have online. So I'm seeing a whole lot of things rolling out now. It's a little faster than I can manage, so I just take a few. However, when we have a replay, you can go and look at what is there. All right, so let me see now. I'm seeing David saying a lot of things. All right. There was a rapid increase in the rate of transpiration due to, I'm not too sure which question you're answering there, David. I'm seeing a whole lot of things that you're saying. There was a rapid increase in the rate. There was a rapid increase. David, please don't do that. Don't do that. Don't do that. That is spam. All right, you're spamming there. Don't do that. All right. So there was a rapid increase in the rate of temperature. Rate and temperature. No, we don't use those together. We're looking at the rate of the water loss. All right, so we want to do that. Stability, probably due to the closing of the stomata. That is a plausible answer. And we're going to look at the closing of the stomata, but just give me a bit. Little or no change occurred in the environment, therefore the temperature, the transpiration rate remain constant. Now, right, while this sounds plausible, we have to be mindful of the fact that we were having changes all along, and then it stopped. So we can't say little or no, because we just had this sudden rise in temperature or wind speed or something, and then it just went back. What happened? So you have to look at what could have caused the plant to stop that large the large transpiration rate. What could have caused that to have been reduced? Now, somebody said rightly just now, as the light intensity increased and as the plant started losing too much water, the plant went into guard mode. Now, when the plant went into guard mode, what happened is that the plant would have closed the stomata in order to conserve water. Now, in conserving the water, of course, the rate of transpiration would have slowed and it probably would have maintained that constant. Now, another plausible thing, I'm sorry, I can't see everything in the chat. I'm very sorry. So I might not see some of the stuff. Another plausible thing is that you might have had a cloud cover. So the environmental condition pretty much changed quickly. Not too sure what would have caused that. You could have had a cloud cover. You could have, it started raining or something like that, and that would have probably affected the experiment. I know as a fact that when we are doing this type of experiment at school, usually we have to go in very early on a Saturday, and we have the setup there for the entire day. And any changes in the atmospheric condition, be that increase or decrease in wind speed, increase or decrease in light intensity, increase or decrease in humidity, increase or decrease in temperature, all that could affect the shape of your graph. So one, we could look at the stomata being closed, and two, we could again look at a sudden change in the environmental condition. Or the key not working properly. All right, I'm so sorry. Now that you know exactly what you should do to ensure that it is, to ensure that you don't spam it and other persons get a little flustered. We don't want that. All right. All right, guys, we are a little empathetic here. We have never had anybody in the room disrespecting another. Even when person would have gone overboard, persons tend to be empathetic to each other. So we don't use words like stupid to each other. It doesn't really matter what persons do. What we do here, if we find that the person continue to be a nuisance, what we tend to do is to just kick them out of the room. So we are going to ask you to respect everyone's view, and let us just focus on what we're here for. And don't be mindful too much of others. If a person become a problem, then you can say, sir, could you address that problem? And we will address the problem. Please do not attack others, all right? Yes, and what you are doing is hurting our feeling as well, all right? All right, so we're addressing that spamming problem address. That's what we do. So don't attack the person and get the thing out of the circle we want to. So I would have removed the person from the room so we don't have to go there. Persons are here to learn, not to play. All right, great. All right, great. We addressed that. We had to remove him from the room because a security concern. So let's move on into the questions. All right, this is another important and our nice thing here. We're supposed to discuss how transpiration helps plants to move water from their root to their leaves. Anybody want to tackle that one? Or you want me to treat with it? Is there anybody who would love to address this? What's the answer for which one? Okay, you want me to go back to that question? Okay, where we had that constant, where we had the constant with the line going straight across the screen at 40, your answer could have been either of two things. One, there was a drastic change in the weather pattern where we would have had a cloud cover. We would have had a cloud cover. So what would have happened is that point of the day, pretty much things became constant. So the temperature fell, the wind speed fell, the humidity went up where the plant could have dealt with it. Or the most plausible of all is that the plant would have lost so much water between, is it 9 and 11? The plant lost so much water between 9 and 11, and now the plant is going through what we refer to as transipient wilting. Now, the plant going through transipient wilting, the plant will do everything in order to protect itself from dying or from experiencing permanent wilting. So what the plant will do, the plant will close the stomata, thus preventing or reducing that water loss. So the highlight intensity, the fact that it would have lost so much water, it is now in protection mode, so it would have closed the stomata, preventing that excessive water loss. So I think that is the safest and the best answer, looking at what happened between 9 and 11. I hope I answered the question. Okay, now somebody is answering this question on the screen. So water is absorbed. Can't just say xylem vessel for what? We're going to speak to the xylem vessel, just give me a bit. So water is absorbed from the root of a plant through the xylem, and as it reaches the leaf, it is evaporated into the air. This is known as transpiration. But that is not what the question had asked. That's a real nice thing that you've just said, but that is not what the question had asked earlier. I'm not too sure why I'm not too sure what that question is for. Through the leaves into the ear. All right, great. So that is not necessarily what the question was looking at. So let us look at the question, what the question is saying. The question wants us to discuss how transpiration helps plants to move water from the root to the leaf. How is it done? All right. Now, if you are looking in your textbook, you would have realized that there are about 3 to 4 ways in which water tend to move from the soil through the upward through the plant. Just let me draw something on the screen before I answer that question. All right, just let me draw something on the screen before I answer that question. All right, great. A lot of persons are having fun. All right, so I want to show you this. So water move up the plant by capillarity. Now, if you look at, I'm drawing a straw here. So it has a very small space in between, providing this is not drawn properly. We have another straw here, and it has a bigger space. We have another straw here, and this straw even have a much bigger space. So we could call this straw probably A, and we could probably call this straw B, and we could call this straw C. Now, if we had them in a container with liquid, and providing that they have been immersed pretty much at the same level, what you'd find is that the liquid would move higher in this straw than it would be in this, and then it would have moved not so high in this one. Now, this is as a result of what we refer to as capillarity. The smaller the bore, the higher the water will rise. Then there's what we refer to as the osmotic pressure that causes water to go up the xylem. But let us look at the answer for this particular question. In answering this question, we need to be familiar with the term cohesion. Cohesion. So what happens is that as the water leaves the plant, it creates what we refer to as a transpiration pull. Now, this transpiration pull, it is as if you are holding on to your friend and you are pulling your friend. This is what we refer to as that cohesive force, where one water molecule is pretty much attached to another water molecule, and as it moves through the xylem by the process of transpiration, the pull of the transpiration, or the loss of the water which create this transpiration pull, it is pulling water from the soil up through the xylem, up to the leaf. So it's because of a process we call the transpiration pull, and of course, the water being able to attach to each other through what we refer to as cohesion. So you would have heard about the water particle, the cohesive force between the water particle, and you'd have heard about adhesion of a water particle to the side of the xylem vessel, thus making it move up the xylem vessel quickly. Let me see what's happening here. Water is absorbed by the root here, and osmosis then travels to the xylem vessel of a stem. Guys, all this is fancy information. But if you want to find this information in your textbook, you are going to go on over, look for transpiration, and depending on which of the textbook you are using, I know that there's a nice diagram in, I think it's Lydia's summary book. I know that there's a nice diagram in that book. But the whole idea here is that the answer is surround what we refer to as transpiration pull. You could look for that on Google, and cohesion. Those are two nice words you want to have in your answer there. All right, root air pressure is a nice word. Water. Yes, the water goes through the stomata, but the question here is how we know. And we are saying the transpiration pull, that force as the water leaves the plant, it is pulling water behind it. For those persons who have, I don't know if you have ever been exposed to this. You are using a piece of hose to pull some water out of something, and as soon as it starts pulling that water out, then it just start running through the hose as if there's a pump there. It's that same type of effect with transpiration pull, where it is pulling the water as it leaves the plant. So to answer this question, you must use this word, transpiration pull, and you must use cohesion as well. All right? Yes, it could be partly correct, but please be reminded that CSEC doesn't award half marks. So I want to ensure that you are here and you get it correct. All right? But don't worry yourself too much if what you said is not exactly what I said. Don't worry yourself too much. You shouldn't feel bad. You should actually feel great that you have participated. All right, great. So let's move on. So here's another question, and this is one that we refer to as, I like to refer to as being textbook. Now, while absorbing water from the soil, plants absorb mineral salts such as magnesium, calcium, nitrogen. State one role of magnesium and one role of calcium. So tell me in the chat there, what's the role of magnesium in the plant and what is the role of calcium in the plant? We're looking at the 2019 biology paper 2. It's a May-June paper. No half mark. I'm sorry, no half mark for CXC. So even when we are marking your SBA, and you get 7.5, you are given 8. That's the CSEC policy. If you got a 7.5, then you're going to realize you would have seen 8 for your SBA. Okay, yes, Brittany, all calcium makes a cell wall. Great. What about magnesium? What is the function of magnesium? Magnesium helps in making of protein. Is there any other function? Very good. Magnesium powerhouse for photosynthesis. So magnesium would have been very important for chlorophyll. All are very good answers. All right, so for the production of chlorophyll, magnesium is going to be very important, and calcium is for cell wall. What about protein? Magnesium prevent the leaf from obtaining yellow color. It's not so much obtaining yellow color, because to obtain it, it sounds as if we want the plant to have this yellow color. No, if there is a lack thereof, then of course the plant would show that there's some deficiency and would give you that yellow color. All right, it assists in photosynthesis. But tell us about protein now. Sorry, tell us about nitrogen. Nitrogen is used by the plant to make protein. So there's 2 reasons why plants need protein. Two reasons why plants need protein. Tell me in the chat 2 reasons why plants would need protein. Two reasons. All right. Plants will always need protein just like anything else. And the simplest way to answer this is to say that it is responsible for the growth and repair of body tissue. Right? So you're going to find answers that are not really specific to that, but that is pretty much around the general tone where the answer for this particular question would have gone. All right? So we are coming down. I plan to do 2 questions, but based on the time we took to answer this, I don't know I can hop on into the other question. But I'm just going to be doing just a part of question 2, and then we can pick up tomorrow. I do hope that you're going to be here early, armed with your textbook so you can answer the question. Usually I allow students to answer questions than me telling you what the answer should be. So we're looking at this diagram here, and it represents a carbon cycle. I'm going to make it pretty big for you. So it pretty much represents a carbon cycle. Now, we are sure that questions from this question number 2, will be on the exam. We are certain of that. I haven't seen the paper, but CSEC said it in the broad topic, and I'm going to show you as we go through this question. Now, the diagram here shows, look at 1, what is happening at 1. Look at what is happening at 2. Look at what is happening at 3. So these are the things that we want to look at. We want to pay attention to that. We want to pay attention to that. We want to pay attention to that. And we want to pay attention to that. And our views are going to be different here, but never mind. So let me just minimize and tell you what the question is. So now that you can see it, you are supposed to state the name of the processes named 1 to 5. So state the name of a process 1 to 5. In answering the question, you are going to say 1 and what it is, 2 and what it is, 3 and what it is, and 4 and what it is. Write it in the chat there for me. Let me see how much you have been learning. Your teacher must be very, very happy that you're here. There are some persons out of the block really, really quick. All right, great. So 1 is photosynthesis. It is biology or HSP. Well, it is a biology paper that we're doing, but the content will be useful for those students who are doing HSP as well. All right, more so moving on. I don't think we have any other plant question on the paper. All right, so I'm seeing that 2 is for respiration, 3 is for combustion, 2 is for respiration, and I'm seeing 1 photo. Oh, somebody make it car make it very, very nice here, saying photosynthesis 1, respiration 2, combustion 3, and 4, respiration of decomposers. Now, I want you to pay attention to decomposers they are being used in presentation. Now, that is pretty much the answer. I'm going to scroll on up. Look at, I'm not sure if it's Keitra Car or Keitra Care. If you look at the answer there, I don't even know here. If you look at her answer, you are going to see the answer that we're looking for. Photosynthesis, respiration, combustion, and respiration again. I'm happy that we had that view because I have worked with other students who think that this should have been fossilization. But be mindful that this arrow would have, if it was going this way, then here probably would have had fossilization. But while we are sure that content from this question is going to be on the exam, somebody asked me when the broad topic came out, what are decomposers? So here we have decomposers, and decomposers are really, really important in the carbon cycle. They are important in many other areas that we're going to look at. When we look at the types of nutrition, remember when we look at the type of nutrition, we say that one type of nutrition is autotrophic. We say that the other is heterotrophic, and the third is saprophytic. Now, under saprophytic nutrition, you are going to find decomposers, and you are going to find detritivores. Now, under decomposers, you are going to find fungi. You are going to find fungi, and you are going to find bacteria. Always remember that. So under decomposers, that's here, we are going to find our fungi and bacteria. And under detritivore, we are going to find things like wood lice, earthworm, ants, millipede, and the list continue. So we know that we are supposed to study for that. That bit of information will appear on the paper because CSEC did say so when they sent out the broad topic. And it's a very narrow topic, so there you have to study everything. So knowing the carbon cycle is very, very good, and knowing about decomposers is even going to be better. Now let us look at B. Name one type of organism responsible for decomposing organic waste. So one type of organism that is responsible for decomposing organic waste. Let me see what you have in the chat there. One type of organism. So Zaria is again saying bacteria and fungi, they are responsible for decomposing organic content. Very, very good there. Bacteria, one, but some persons who are armed with the information will give more than one, and that is accepted. All right, so we have fungi and bacteria, and they are pretty much from a group that we refer to as decomposers. I want to clear up something here. I don't want to go insects. Let us not go insect now, because we talk about decomposers, and I'm going to show you why we're not going to go insect. If we are going to go insect, we couldn't say decomposer. We would have to say that they are detritivores. So if you're going to talk about insect, you'd have to put them in the group of detritivore, because the detritivore, they are larger. The detritivore, they are larger than the decomposers, and of course, the detritivores are larger than the decomposers. Remember that the decomposers are our bacteria and our fungi. Another thing I need to say to you on the matter of nutrient and decomposer, which persons have been asking about, is that, no. I am not saying that insects are detritivore, but we could say that there are some insects that are detritivore. So I am not making a blanket statement here to say that insects are detritivore. That's not what I am saying. All right? Great. Maggots would fall into the detritivore group as well. All right, great. Let us move on with this bit of content. Before I move on, I must revisit the content of nutrition. Now, usually you're asked to make the distinction between the three types of nutrition. And the three types of nutrition, remind me of them in the chat, please, before we move to the other question. The three types of nutrition, I mean in reference in this situation. Yes, in this situation, an insect would have been a detritivore. All right. I'm not too sure why 5. You're talking about holozoic nutrition. And holozoic nutrition is a type of autotrophic nutrition. So you're talking about the ingestion and all of that. The person, Kelly, that's not what we're talking about. Sorry. We're talking about those three root, those three big group of the three big group for nutrition, and then we are going to have sublet from them all. All right. So let us talk about the three groups. So good thing you're here this evening, Kelly. The three groups are autotrophic nutrition, and autotrophic refers to self, very well widely. Autotrophic refers to auto self feeders. And then we have heterotrophic, which relies on, it pretty much, they rely on other organisms for food. And then we have the saprophytic nutrition, and saprophytes, they are relying pretty much on the organic remain of other organisms. If we're supposed to put it simple, we can say that with autotrophic nutrition, as it were, with a plant is using simple inorganic substances to make organic compound. It is this organic compound that the heterotrophic organism would have been feeding on, and when they would have probably died, or when they would have passed on, whichever the word you want to use, then we are going to have the detritivore and the decomposers are pretty much feeding on them. So we are stopping right at feeding on them, and we are going to be looking at the other question, which could be on your paper this year, as you have to pay attention. Anywhere it's a decomposer, you need to pay attention to that, because CXC did say that that is going to be on your paper this year. Now, explain two ways in which this type of nutrition carried out by the explain two ways in which the type of nutrition carried out by the organism named above is different from that carried out by plant. Let me make this very, very simple. All you are going to say, how saprophytic nutrition is different than autotrophic nutrition. Tell me two ways in which autotrophic nutrition is different than saprophytic nutrition. Tell me in the chat, that is what is required here. Tell me in the chat two ways in which saprophytic nutrition would have been different than autotrophic nutrition, because plants are autotrophs and decomposers are saprophyte. So tell me two ways in the chat in which they differ. We're looking at the Biology 2019 paper 2. We are going through question 1, and hopefully we'll be able to complete question number 2. And it's pretty much a precursor. We're looking forward to tomorrow at 5:05 when we're going to be going through this paper and another paper, and we're going to be doing the entire paper, through which I'm going to be breaking and giving you little content, as it were, for the broad topic. So whatever I'm going to be covering, it's going to be on the broad topic. So for the 2019 paper, which has a respiration on it, we're not going to be doing respiration because respiration is not going to be on the exam. For the students who are a little anxious about HSB, Monday is biology, and we are going to be looking at HSB Monday evening. We are going to be looking at HSB Tuesday evening, and of course we are going to try to put some HSB in over the weekend. But we have been doing a lot of HSB, and there's a lot of past people that we have on the channel that persons could of course use. All right, so you are watching Mr. Wilson live, and we are streaming from TCP Academy. For those persons who are going to be doing biology or HSB come September, please sign up to our classes at tcpacademy.teachable.com. All right, so that's a paid version or a paid platform where you can find just about everything that is a part of the content that you should cover. So let us look at what persons have been saying. Autotrophic nutrition occurs in plants, whereas heterotrophic, so we're not looking at autotrophic and heterotrophic. Now we're looking at saprophytic and autotrophic. But very good move there. All right, saprophytic nutrition relates to organism feeding on dead or decaying organism, while autotrophic nutrition, plants particular producing their own food. All right, so that is one part widely. What about the other part? It says 2, and you have just provided 1. But that's a great one though. So what is 2? Let us see. Oh, you have 2 down here. Saprophyte release nutrients back into the soil. Autotrophic release oxygen back into the atmosphere. That is nice, but I would have gone somewhere a little different. But that is sort of acceptable somewhat. All right, autotrophic nutrition is when organisms make their own food while saprophytic feed on decomposed or decomposing material that is being decomposed. All right, great. But here, everybody keeps saying one. If I ask you two differences between a boy and a girl, to tell me that the boy has a penis and the female has a, the female reproductive organ, you have just told me about one difference there. Because remember, difference, if it's difference, it's always going to have a for and against. So when we have a pair of a for and against, that is just one reason. And then we need another for and against. Understand? So we can't just say one and just leave it there. So once you're asked about two differences, you must have two different for and against. Easiest way to put it. Two different for and against, not just one. All right? Sir, was I wrong? I'm not seeing everything, so forgive me if I'm not responding to everything. As I catch them, I say a thing or two on them. Saprophyte relates to nutrients, but release nutrients. All right, the answer here you're having whitey for 2. I think this answers a question, or it's going to answer a question that will come later on the question 2. But what I was looking for as it relates to saprophyte and autotrophic nutrition, one, we spoke about making their own food, and we spoke about one, feeding. I was looking for the other thing is that autotrophic nutrition uses simple inorganic substances for their food, while saprophytic organisms, they use organic substance for their food. So autotrophic, they use inorganic for food, and saprophytic, they use organic. So that was the other difference that I was looking for. All right. So what you've said there, it is true, but I don't know that it is so much of a strong answer. I'm sorry. I don't know. You might have said that, but like I said, I am not seeing everything. The screen is going so fast. I'm not seeing everything. I am sorry. All right. So what I tend to do is to validate, and if you are there, congrats. All right. So let's move on down. Here we're supposed to state 2 reasons why the type of organism named in BI is important. Now here you're answering the question rightly. This is a question that I said would have come later. State 2 reasons. So we can look at question number 2 for those persons who are trying to zero in on questions that will be on the exam paper. Question number 2 on the 2019 paper, based on what CSEC is saying, we are going to be having some repeat or some question of this type on the paper that you'll be doing Monday, based on what CSEC said in the broad topic. All right, great. So here, the answer here state 2 reasons why the type of organism named in BI is important in an ecosystem. So let me see what you have as your answer there. Remember, I'm just going to be just grabbing some. I won't be able to see everything, but I do appreciate all the responses, be that they are good or bad. We're going to learn from them. So if I didn't read yours, forgive me. I'm just going to grab one that comes up pretty quickly, or one that I see at a glance. All right, just give me a second. All the lives are saved. You have to just go to the videos. Once you know the name of the video, you can go to the live and you will find them. We have never deleted a live. No, unless it's like a crash live. But if it's a live that goes up an hour and so on, we really don't delete the lives. We don't do that. All right. I'm seeing some questions, some answers coming in. They break apart dead organism into simpler inorganic substance, inorganic material, making nutrients available to primary producers. This is a nice one, Andrews. That's a nice one there, Andrews. All right. holder. Fungi. Fungi are important for breaking down organic matter and release carbon. During respiration, they do release carbon. Where is that now? Oxygen and nitrogen into the soil and atmosphere. All right, what I'm looking, okay, I'm seeing something here. Cycle, recycle nutrients. Two, getting rid of excess waste. I think this is short and to the point. So, of course, decomposers, they are very, very important to the environment because they help to cycle nutrients and, of course, to release that trapped nutrient in that decaying organic content. They make that available so that other organisms can use it. Now, I'm seeing a nice word coming up, recycle, and I did a video. It's on my channel that looks at the 3 R's for sustainable environment. And the 3 R's are going to be reduce, reuse, and recycle. Now, I want us to know that in the order that they were named, reduce, reuse, recycle is the order of importance. Now, to recycle is the least efficient of the 3. However, everybody would have known about recycle and thinking that it is the best of the 3. So I suggest that you go on over to my channel and watch. It's a short video. That's a part of my short. So I think it's probably less than 10 minutes. All the shorts are less than 10 minutes. Probably you want to look at that. All right, so let me just look at the other question. I'll have to drive out anytime now. Suggest 2 reasons why carbon dioxide is described as a greenhouse gas. Suggest 2 reasons why carbon dioxide is described as a greenhouse gas. So I want to show you something here. I'm going to draw a diagram on my screen. So I want you to pay attention. Now, this is the planet Earth. All right, so we have the various landmass. Great. So on planet Earth, we have respiration taking place, combustion, fossilization, you name it, all those stuff, right? Now, they are giving off carbon dioxide, which is one of the many greenhouse gases. Carbon dioxide is just one. The thing about carbon dioxide, it is the 4th most abundant gas in the Earth's atmosphere. Now, carbon dioxide become a greenhouse gas. Now, this is what happens when we talk about a greenhouse. So I'm just going to draw a box here. And this is a glass box, right? Now, we have wavelength of light coming in from the sun. So we have the sun here. Nice little sun with a little iron thing. This looks like it's a girl's sun, right? So we have the sun coming in, the rays coming in here. Now, when the rays come in and they hit here, what that means that they might reflect here and then they come down and not everything is coming out. So what you find happening is that most of the heat energy is being trapped in the envelope of the Earth's surface. So this is what really happens around the Earth. So we have this blanket of carbon dioxide that is emitted among other gas, and it is forming this area here around the Earth. All right, good. So what happens is that as the sun energy comes in here, the same amount that comes in is not the same amount that goes out. Some of the energy is going to hit here on the carbon, come back into our atmosphere, hit here on the carbon, come back into the atmosphere, hit here on the greenhouse gas and come back into the atmosphere. Now, this whole effect is what we refer to as the greenhouse effect. That whole effect there is called the greenhouse effect. Now, what I want you to tell me, I want you to suggest 2 reasons, pay attention to 2 reasons why carbon dioxide is described as a greenhouse gas. 2 reasons why carbon dioxide is described as a greenhouse gas. 2 reasons why carbon dioxide is described as a greenhouse gas. This is going to be the last question, as in question number 2 for this evening, and we will rejoin tomorrow or probably early tomorrow morning. I'm not too sure what my schedule is like. I will try and look at that. All right, great. So persons are saying that it absorbs and emits radiant energy within the thermal infrared range. Kara said that you're a physics student. It traps heat. It traps heat just like a glass rod. Okay. Of a greenhouse. Our glass wood. I think that should be wood. Prevent the emission of reflected UV rays. So one of the things why it is called a greenhouse gas is because it traps pretty much that heat energy in the Earth atmosphere. That's one. And two, it causes the Earth atmosphere to increase in temperature. What is that? The universal sound for ice cream truck. I don't know what this person is asking. All right, so pretty much we want to look at that. So question number 2 of the 2019 paper, I want persons to revisit this question because some of these questions, I am almost confident that some of these questions are going to be on the 2019 paper. With reference to the carbon cycle, suggest 2 strategies individuals can use to reduce the amount of carbon dioxide in the atmosphere. This is going to be our last question for the evening. What is your answer for this question? There it is on screen. What could we do to reduce? All right, so please be reminded to like, share, and of course, subscribe. I want to also remind you that we're going to be having some books coming out for September. We're going to be having a whole blaze of science content. We're going to be having some storybooks, some really interesting storybook. Those are coming out. I am a little worried. I spoke to my business partner earlier, and I said that I will have to put books on hold for a bit as I try to assist these students in getting exam ready. I know that biology is on Monday and HSB is on Wednesday thereabout. So please be reminded to like, share, and of course subscribe. And of course, give the videos some love where the videos are due. That love. All right. And if you have something to share with us, please feel free to share it. As you watch our many videos, we have about 3 multiple choice videos that we would have corrected things on. Go down into the description to see what the correction is. And if you watch any video and you have any concern, don't be afraid to respectfully communicate it to us because we understand that we are not the keeper of knowledge. And where we are corrected or to be corrected, we will look at it with the content that we have available. And if correction is needed, we'd be glad to do so and render an apology. But for the greater part, those videos have been there for quite a while. And I think we've had about 3 corrections, having looked at probably thousands of questions. So the rate is really, really good. It's insignificant if you ask me based on the amount we have put out. But it is significant to have 1 error. All right. So we could do reforestation. Let me look at the answers that you have here. And I'm going to tell you what I was looking for as my first answer. So persons resort to reduce the use of pesticide. That is sort of far-fetched to me. Burn less fossil fuel. Yes, that is true. Reduce forests, reduce factory emission. Yes, hearing all of that. But what is the remedy? Decrease the combustion. All of those saying the same thing. Green technology. Yes, green technology. But what is green technology? All right. Plant more trees. This is plausible. I love this one. All right. Reduce burning. All of those reduce. They are correct. Reforestation. Guys, what I want you to do is to check out the difference between reforestation and afforestation for the biology student because I am almost certain that is going to be on your multiple choice paper. Reforestation allow trees. All right, great. So what I'm looking for the use of, oh, is it here? Somebody says solar energy. So I'm looking for renewable energy, the use of renewable energy. And renewable energy would include our solar, our wind, our hydroelectricity, our geothermal, our wave energy, our tide energy, our hydrogen fuel cell, and the list goes on and on where renewable energy is concerned. Yes, we need to consume less fossil fuel, hence we'll have less burning. Yes, we need to plant more trees because trees serve as carbon sink and they will absorb some of the carbon out of the atmosphere. So those are all plausible. We need to reduce, reuse, and of course, if we can do without recycling, that would be good, but we need to recycle as well so that we don't have recycle. Recycle. We need to reduce and reuse so that we don't have to burn these things for them to get into the atmosphere. As it were, for recycling, yes, if we recycle, probably don't have to burn stuff, but remember, recycling is an inefficient process because when we recycle, we are making something into something new. And when we make it into something new, we would have been polluting the atmosphere just the same. All right? So we want to pay attention to that. Remember, the least efficient of the three is going to be recycling to the atmosphere because we are also polluting as we recycle. Use less CFCs. All right, so let us just look back at that question as we make our way out with reference to the carbon cycle. So just two strategies. So carbon cycle, we are trying now to reduce the amount of carbon entering the air as a result of combustion and respiration. And if it does happen, what we could do, we could plant more trees, we could reduce, reuse, and recycle so that we don't have to burn, our combustion doesn't have to take place. And we could go to alternative source of energy, which are our renewable energy, just to include solar and the popular renewable energy in the Caribbean. They are going to be solar, wind, and hydroelectricity. That takes us to the end of the show for this evening. It's much longer than I thought I would have been here. I am very happy. I'm grateful to have you. I'm sorry that you were not all here from we started in September last when we were doing the labs and sending out the many animations. We have a lot of animations that we would have written specifically for students of the Caribbean, persons who are doing CXC. You weren't here from September, you are just joining, but those students who are in grade 10, please ask them to like, share, and subscribe to the channel. Those persons who are going to be doing HSB for the first time come September, they will be doing the labs, the SBA labs. So HSB now carry a SBA component for the new set of students. The students who are in grade 10 now, they are going to be doing the SBA, and we are going to be covering that on this channel. So they want to be here. We're going to start off come early September. The classes will start off in September. We're not going to be doing 3 classes online like we did this year. This was a special year for COVID. We tried to reach everyone and make sure that everybody was all right. And I think we did a good job at that based on what we've heard from the students online. We don't know the students. We are teaching students. The last time I checked, we are in 21 countries. And when I checked today, the number has significantly increased. I don't know if persons in Zambia, they are doing CXC, but I realize I have a whole lot of persons out of Africa using the channel, and we're really grateful for that. We have a lot of persons from the Caribbean. Trinidad is our main fan. They are from Trinidad. Guyana is also doing well on the channel, but we really need persons. Jamaica is top of the list. Jamaica is like top of the list. But we invite persons from other Caribbean islands to join. Really, we don't even need to know your name. We just want to ensure that we're imparting knowledge, and of course, you are benefiting from what we're doing. Before I go, I want to remind us, for those persons who are going to need special help for September, for those persons who need just to look at a particular part of the syllabus, for those persons who need for us just to do a particular explanation, we have a price for everything, a pretty attractive price. Our payment plan, it's pretty flexible. If you're in Jamaica, there's a whole lot of things you can do. We're going to be rolling that out come August, the entire payment plan. So, of course, you are here, we have your back, and we are going to be taking care of you. We have, like we said, over 300 videos on the channel, YouTube. And most of those videos are going to be there. All the labs that we covered, they are going to be there for those persons who will come next year and need to know how to write up a lab, what they should see in the lab. We have done animations with all the labs. Slow them down for your SBA. so that when your teacher give you that lab to go home and write up, if you come on the channel, you'll see exactly how to write up a lab, whether it be a AI, whether it be a MM, whether it be a ORR, whether it be a PD, and we're going to now put on implementation. We're also going to be adding environmental science and agriculture to the list of subjects that we're offering on the YouTube channel. For the paid channel, we're going to be doing biology and HSP. Thank you very much for joining. Thanks pretty much for the sentiments. Those persons who have been sending in those nice little note every now and then. Thank you, sir. I miss you, that type of thing. Not miss me, miss the class, because I really don't know any of the students. We are really grateful for that. And we do miss you guys as well. Every opportunity that I get to be with you, if you observe, I'm making use of the opportunity. So tomorrow, I'll see you at 5:05. I think Anna will be here tomorrow. I don't know if anybody would love to invite their teacher to join me. I have space where I can use more than one teacher on the platform. I'll be very grateful. So whichever Caribbean island you are, if your teacher wants to join in the session tomorrow, they could just send me an email by the channel email address. It's Extreme Solution, but you have to go onto the channel page to look at the spelling, and your teacher could join me, and I could tell them what past paper we'll be doing tomorrow, and they could, of course, join. I will share the link, and they'll be on the screen. You'll see a teacher with Mr. Wilson live, and we're streaming from Kingston, Jamaica. It's my pleasure. Take care until tomorrow. Continue studying for the rest of the night. Bye-bye. All right, so that's it for me. Until we meet tomorrow, take care. It's Mr. Wilson Live. I'm just trying to play. Adios. I'm trying to get a video up on immunity. All right, so it's on screen now.
What's the difference production? Today we're looking at types of immunity, and of course I am Mr. Wilson from CSEC Biology TCP. There are two types of immunity: active and passive. Let's look at the animation for active immunity. Active immunity occurs when an individual is exposed to a disease which causes the immune system to produce antibodies specific to that disease. It is important to note here that the individual would have been exposed to the disease, and that immunity is of course being developed as a result of action within that person or organism. So here we have a fellow being introduced to the ranch, and with him he brought pathogen, and you're seeing the pathogen populating the screen in red. And as the pathogen enters the environment, you're seeing that the lady is developing some antibodies that are of course going to be guarding her against this particular pathogen. So of course she will not become ill as a result of her building her defense from within. So here she's exposed to the disease, and as such she would have developed some resistance. With passive immunity, what happens is that the antibodies are of course given to the individual rather than them producing it through their own immune system. So in the passive, you're seeing that it is given to the person, while in the active, it is the person who is actually making the antibody. So in passive, the antibody is made elsewhere and given to the individual. However, in active, it is of course made within the individual. And we're going to continue to reinforce that throughout this video. Here we have examples of passive vaccine there we're seeing, and of course a mother with the fetus, and we're seeing a mother breastfeeding. Now, immunity could also be considered as natural or artificial. With natural immunity, it is organic. Natural innate active immunity. This is where we start now to think about our exams. Now, these words are all words that they carry specific meaning and of course direct you to the particular immunity. So natural, it is organic. It has no influence of man. Now, this type of immunity is an immunity that you are born with. How do we know you were born with this immunity? It is innate. That suggests that you were born with the type of immunity. Now, where do we get the antibodies from? Active here tells us that you are making the antibodies. So whenever we see active, it means that the antibodies to safeguard you against that particular pathogen is made within the individual and not with external assistance. Then there's also natural innate passive immunity. And let's decode. Natural, it's organic, it has no human interference. Innate, meaning that it is made within a organism. And of course, passive here mean that it is given. It's something that is given. It is passed from one person to another. When passive, we talk about passive, you are given the antibodies rather than you making the antibody. So here, the offspring gets the immunity from the antibodies that are of course produced by mom that crosses the placenta to the fetus. So the antibodies are not made in the baby. The antibodies are actually made in the mother, and of course passes the placenta to the baby. The baby also acquires some amount of immunity from the breast milk. So passive here suggests that you were given the antibodies. It's not that it was made within you. So the baby was given the antibody. It's not a case that the baby is able to make the antibodies for itself. Now innate, of course, when the baby is born, or it is made within. Innate, when the baby is born, will born that with a short-lived immunity, and it is, of course, innate speaks to being within the individual. Why is this youngster running? It seems so happy. Of course, he would have acquired acquired active immunity. What does that mean? Acquired, the immunity that develops after birth. So immunity, if we were supposed to compare, we'd compare acquired to innate. So if it's from birth, then it's innate. If it's acquired, then it's after birth. If we were supposed to compare natural, it would be compared with artificial. If we were supposed to compare active, it would have been compared with passive. So this type of immunity is one that develops as a result of exposure to the disease. Example, smallpox and tuberculosis are examples. Now, this youngster probably would have been exposed to the disease, and having exposed to the disease over time, he would have gotten some immunity. So there's a great possibility here that he is now told that he's no longer suffering from the disease, he's immune to the disease, because his body would now be making the antibodies to fight off the particular disease. Who wouldn't be happy? Hee-hoo! That's what most persons would be saying. Now, artificial immunity is one that is, of course, introduced, or it has direct human influence. So whenever we go for vaccine, that is a good example of artificial. Now, it could be artificial acquired active immunity. And let's break this down. Artificial meaning that it has some human influence. Acquired meaning that it was, of course, developed after birth. So you were not born with it if it is, of course, acquired. And then active, even though it was given to you by a human, it is within your body that the antibodies are going to be made. So with this type of immunity, artificial acquired active immunity, immunity that developed as a result of individual being given a weakened form of the disease. And the disease here is weakened by eating, or we could use formalin, or we could re-inject several times, and of course weaken the pathogen to a manageable form that can be injected in someone. Usually it is administered through vaccine. Examples would have been that for tuberculosis, polio, and BCG that we would have received in the early years of our life. It's very important for you to pay attention and look at the photographs that we're using in the pictures, as they are giving you prime examples of each of the type of immunity. Now, artificial passive acquired immunity. Artificial here, human influence. Passive meaning that the person was exposed to the antibodies and not to the disease. So here the person would have been given the antibodies because it's passive, and acquired meaning that this resistance, this immunity actually developed after birth. So we have both on the screen, and we continue to emphasize that when you get to the exam, you can break down this long name, artificial passive acquired immunity. What does it mean? And if you were supposed to see passive acquired immunity, what does it mean? And if you were supposed to see passive immunity, what should we understand from this? So here we have broken it all down. We have given it the meaning for all the words in the names. So you should be able to map this nicely when you get to the exam. Now you're seeing this, and this one is synonymous with bites from snake. Now, it is acquired through the introduction of antibodies directly into the individual affected by the disease. And usually you would have seen my first video on serum and plasma. Here we have what is called antiserum, which is used to treat this type of problem. It is fast acting but lasts for a short time, and it is used during cases of emergency where somebody is bitten by a snake or where the person is suffering from tetanus. This type of a vaccine is administered so that there is quick response and the person could of course recover quickly. If you look at this young man, he was bitten by a snake probably, and of course he's been injected probably with of course antiserum to ensure that he will survive. So looking at the snake, it reminds us that it is artificial passive acquired immunity. We want to ensure that we are paying attention and be reminded that you could go over the slide however many times you so desire, so as to make sure that you understand well that which we have covered. We have just looked at what's the difference, and we're looking at type of immunity, one might say types of immunity. I am Mr. Wilson from CSEC Biology TCP for TCP Academy. Please be reminded to like, share, and of course subscribe. And when you do, click on that notification bell and select all, so you'll be notified as soon as there is a new publication. Join us on a Wednesday, Friday, and Sunday at 5:05 p.m. for live classes streaming from Kingston, Jamaica. Thanks for stopping by.